you must have like the. So I've uninstalled all the like JMF spyware nonsense. Oh, they've marked me as untrusted, but that doesn't really impact my.
Oh no,
life all
I
that
mean.
much. Oh. I mean, maybe Amy just doesn't care. Okay.
Oh, Francesca.
Okay.
Well, I figured in the I think for the actions too. It's like we can share. Oh, I'll do the typing.
Oh, okay. Okay. Great. Maybe you should sit over here so you can hassle the presenters.
Oh, do you want me to do that?
You should probably get started.
This is cool. But yeah.
All right. Oyez, oyez, oyez. Please take your seats, everyone. This is Secdispatch. We're going to dispatch some stuff securely. You may notice that there's some different faces on the stage here. Kathleen was unfortunately unable to make it, so Nancy is filling in her place. And we have one brand new co-chair, Francesca Palambini. Can we have a round of applause for her, please? All right. So, note well is the same as usual. Please note it well, including your obligations with regard to IPR and disclosures. As a reminder, this is our process. We are not here to adopt documents. We are not here even really to develop technologies. We are here to figure out where work goes. So, should it be done in an existing working group, dispatched to AD sponsorship, or should we not work on this at all? We have this range of possible outcomes. So, keep those in mind. Our goal for each of the presentations today is going to be to come to one of these conclusions. So as you're watching the presentations, think about which of these conclusions might be appropriate. Here's our agenda for the day. We're in the first slot right now. We have 5 topics looking for dispatch. We have a bit of an overflow slot because we are a little short on time. Ben, I think, has opted out. So we have one there, Brian Campbell, who didn't have a draft, so we got put in overflow. And is kind of looking for interest there. So any agenda bashes before we launch into this agenda? All right, Dr. Paulo.
Is this the one you have two?
Yeah. Okay, hello everybody. Welcome to Secdispatch. I'm Max Para. I work with Cable Labs, and I'm going to present about addressing public key algorithm uncertainties with composite crypto. This work started a couple of years ago. It's in collaboration with other companies like Entrust Data Card, Cisco Systems, Izara, and DigiCert. So, what is the problem here? Well, with the announcement about quantum computing and lots of investment in this technology, we live in an era of uncertainty. Specifically in cryptography, we suffer a problem where algorithms that we use today might fall apart, right? But this is a very uncertain period. We don't know if that happens, and we don't know if lattice, for example, schemes are strong enough. So, possible workaround would be to use hybrid solutions where you have multiple algorithms that can be used together to secure some data, like certificates. Some initial experiments for deploying some quantum-resistant algorithm have been published. I sent an email before in Secdispatch mailing list. So just keep in mind these results. Is not for all algorithms. These are algorithms that have quantum keys that are relatively small, but still, it seems that the situation might not be that tragic. So, Why we are here? Well, I work in cable, and we use a lot of certificates for many different things, and its use is going to be just increase with the new platform that we're going to deploy for the 10 gig. And one of the questions that we're facing today is it possible to protect our infrastructures in a transition period, right? So applying what could be said as deferred algorithm agility. So are your PKIs going to be secure in next 20 years or 30? So we have this problem. We have to protect ourselves in a transition period that's full of uncertainty, right? There are currently different solutions for this, and we're going to go through them. These solutions being discussed on the mailing list and some considerations are useful to make. So multi-chain, so using multiple certificates, using extensions in certificates to carry additional keys and signatures, or using a composite crypto, the one that we work on with all these other companies. All these have some merits and some drawbacks, and let's go through them. So using multiple certificates seems a very easy solution. Great for negotiating protocol. I can select which one of the certificates, traditional one or post-quantum one, I send to the client, depending on its capabilities, so I don't have to transfer the keys all the time, right? And this is a big problem because these keys are big, and if you put it in certificates, then, for example, for TLS, the amount of data in the first flight will require multiple round trips. But in this case, you can design your protocols and decide where to transfer these big keys. Where's the downsides? Well, now you have multiple certificates. So if you want to protect the same data, you have to change the protocol to allow for multiple signatures to be used. And for non-negotiated protocol, it might be a little bit harder. The user example for SMIME, where you don't know if the client supports or not the new algorithms. However, the other problem would be, when you have multiple certificates and you apply multiple to the same data, how to link these identities in multiple certificates, especially if your PKI is distributed, might be a problem. And definitely complicates the operation size of PKIs. A second solution is adopted by ITU and uses extensions in the certificates. It was also discussed here in LAMPS. Basically, what they do, they use an extension to put additional public keys and or signatures so that the certificate is backward compatible. There's no critical extension, so it can be ignored by clients that don't know how to process it. However, it's very backward compatible. So clients don't even know that they are missing something. So it could be a false sense of security. Requires changes to the protocols to validate multiple signatures. And of course, in this case, the problem of transferring the keys is present because the large keys are tied to the traditional ones. So you cannot separate them. Probably there's something that can be done there, but it would complicate a lot the schema. So a third solution is the one that we've been working on the past couple of years, actually. And we try to leverage the built-in mechanism for algorithm agility that is in certificates and all PKIX data structures. How we do that? So we define a new public key algorithm. So a new OID, define the encoding rules and processing rules. So the trick here is that instead of using a data structure, we take the data structure that contains a generic key, and then we say, now this is a sequence of generic data structures. And this case allows you to extend the use of public keys and signatures in all the PKIX data structures I said before, and therefore provides compatibility with existing certificate processing rule in the sense that one composite key generates one composite signature, and this buys well with protocols, for example. What are the pros of this solution? Well, you can drop in any of the algorithms that are already defined. So you can imagine a composite key using RSA, UCDSA, and a post-quantum. And you have different classes of devices that will use the different algorithms that they support, for example. Can be extended to combine not only just 2, but 3 or 4, depending on what your use case is. And it's not just related to quantum. Think about this as a tool that can be used anytime you have this type of uncertainty. You don't know how much you can rely on the old algorithm. You don't know if the new algorithms are ready for you, so you can try to combine them. And of course, by using one signature, one public key, etc., is compatible with also revocation information. So you can do OCSP, you can do CRLs. You don't have to define anything else. The downside, backward compatibility requires the support of a new algorithm identifier. This is not new. We do that all the time when we deploy a new algorithm. So it actually goes into the PKI operations very well. The downside here is the large keys are sent every time because they are part of the certificate, so you cannot really extract them from there. One note that the ITU just published, or was published on the mailing list, the X510 DIS that uses a similar approach. So we hope that if some work has been will be adopted, we can try to limit the incompatibilities there. I hope that we can do a good job. So what's the current status of the discussion? Of course, messages have been sent in many different mailing lists, Secdispatch, LAMPS, and PKIX, to try to gather some feedback. Of course, mixed reaction as usual. However, one of the things that came out fairly clearly is that this is a problem that needs to be solved. Many people notice that because of the time frame that we're looking into, the sooner we start to work on this is better. Large PKI providers, I work in an industry where we leverage a lot of certificates in the billions, and other supports like DigiCert and other CSPs, they actually want to work on this because they want to be able to have at least one solution that they can deploy. Other proposals emerge that more towards let's reinvent the wheel. I'm not saying it's not possible. It's always possible. I would like to have one solution that is easy, like the one that we propose right away, and then we can look at how we can optimize, we can have more optimized solutions in the space. Largely, we not heard from the TLS community around this idea, mostly because we didn't engage with the TLS community. But if you guys want to start engaging and telling us what you think, of course, we are aware of the fact that the large keys and the problems for performances here. However, this could be one tool that doesn't require many changes in protocols today. So there could be something. 1 minute, okay. Conclusions, there's been discussion, is a problem that is we should try to solve. We think that composite crypto is a possible tool, not the only one, but one simple tool that we can standardize. And we have two ideas. One is for the problem statement and overview of the solution space, and the other is the solution that we try to propose. Question?
Yeah, my question. Are we in the discussion phase now, Richard? So I can't speak for other applications, but it's a little hard to understand how this brings a lot of value to at least like the web PKI story. And the reason for that is that basically we have two choices. Imagine you have like a situation where we are now, where there's not a valid quantum computer. And then someday there will be a valid quantum computer perhaps, and we're trying to get past that transition point. And so now we can either accept like non-composite signatures, or we cannot. Like we can accept standard RSA signatures and easy signatures, or we cannot. If we do, then the vast majority of servers in the world will only have those signatures. And when there's a quantum computer, we'll be screwed. Conversely, if we don't, then we're basically forcing everybody in the world to get composite signatures, which doesn't seem super likely. And so as a practical matter, I don't see how to like use this in like a web PKI environment. So it's like not like now TLS says like TLS is used everywhere. So like I'm sure there's some TLS environments where it's useful, but it's like really hard to understand how, like in the web environment this works.
There's been some experimentation in the TLS web context with hybrid key exchanges. Could you maybe
Sure.
David Benjamin has some things to say about this as well?
Yeah,
Contrasting
so TLS
that situation would be helpful.
Right. So as you say, TLS has been working with hybrid key exchanges. The advantage of the hybrid key exchange, right, is that it doesn't require the client enforcing anything. It's just like mutual negotiation. And the idea is that it's defense now against quantum computers in the future. But like my general concern about anything along these lines is that in order for it to work properly in like real-time environments, you have to actually enforce, you have to require the post-quantum signature at all times, or the whole thing falls apart. And so, like, I don't see anybody doing that, like, in the mass environments. Now, in non-real-time environments, like, I'm not saying it's not reasonable, but in, like, a real-time environment, it's like, yeah.
Well, I respectfully disagree with you. I think that this solution is very important for specifically protecting keys that may be vulnerable to factorization. So not so much the server sides, but think about CAs, root CAs that we need to protect. So by using this approach, usually you can verifying this type of algorithm is a lot easier than signing. So with software updates, you can actually verify and protect the chain. I don't think there's going to be that much of an impact, or you could think about solution where you deploy CA's level type of multi-algorithm and an entity just using the crypto that you want to use at that time. Because at that point, it's easy to revoke one CA whenever the algorithms are going to be broken, and you know that. You can actually, if you want to revoke a CA and then spin up a new one.
I think you're misunderstanding my ecosystem point, which is that, which is that either the browser accepts classical only signatures or it does not. And if it's
either, yes, it supports a new signing algorithm or not.
No.
It's the same situation that we have if you support RSA or
ECMSA. No, it's not. Because the setting here is that someday in the future, all classical algorithms are broken. And now I cannot trust any signature made with a classical algorithm. And so now so like if you want me to flip that switch and you want me to turn off all classical algorithms, and I haven't already preceded the environment with everybody having non-classical signatures, then I've just destroyed the web, which is exactly what happened when we tried to switch over from SHA-1 to SHA-2. And so in order to actually make this work, what we have to do is we have to go forward by requiring everybody to have post-quantum signatures on every certificate. And then only once that is done, then are we like, well, we're going to stop trusting classical only signatures. And so I don't see us doing that. I don't see the BRs requiring that, and therefore, like, I don't see make progress.
Right. So I think the point is taken that in real-time situations like the web, there are challenges that might. So this might be more suitable to things like software update, where you have more control.
Absolutely, yeah. I'm just trying to answer the question at TLS. I think that for software update types applications like this kind of thing makes sense. Although I do wonder in those cases, why bother with hybrid? Why not just use hash signatures, which we all agree are fine.
Yeah. So we have 2 minutes left. Line is closed after Sean. So please be brief.
David Benjamin. So similar to also on the TLS side of things, when we were doing there was some talk of the hybrid key exchange stuff, and I think one of the things that came up was how to do the encoding. Do you add this like generic combinator thing, or do you just allocate code points for some pairs and move on with life? And the preference, I don't know. My preference, at least, was overwhelmingly for it. Just allocate some code points for pairs or triples or whatever you want and move on with life. And I think this is in the wrong direction here, where if you want to do a hybrid thing, building these combinators and saying, oh, if you have subsets, then it's okay, and all this stuff just adds like a whole lot of complexity, which bleeds throughout the entire system. We went through a lot of trouble in TLS 1.3 to simplify the signature algorithm negotiation. And it's not clear to me this generality actually gives you does anything useful for you. Because at the end of the day, if you're trying to, if your goal is to do something where like a client that doesn't understand C can still accept an ABC, like only understands A and B will still accept an ABC signature, like it's going to go up to some trust anchor. And if the client's if the client has an ABC root in its trust anchor set, if the client trusts an ABC trust anchor, like presumably it knows what C is. So that scenario seems kind of bizarre. And the cost of all of this stuff is that we need to like be able to express the combinators in TLS, the verifiers need this like complicated matching thing. As you note in the slides, we have to move the policy into the crypto libraries, which is actually the wrong direction because the crypto libraries are fairly low level and don't really know what's being used. Like I don't see the benefit of this.
Read carefully the draft. I think that it will answer most of your questions. Pushing in the crypto library actually I think is a very good idea in a sense that operationally wise for PKIs, you're talking about TLS, but I'm protecting my PKI, I need to protect my clients, and I need to protect my infrastructure. So my consideration for now is I need to protect against factorization. All these considerations for TLS, they are very important and they have their place. I think that there might be some other solution that we can come up with that are optimized for these use cases, like for TLS, for example, specific algorithms like some experiments have tried to do. I think we should have a generic solution. It doesn't complicate the operation. Actually, for application layer, is easier compared to multiple certificates or multiple keys. As I showed before, protocols don't need to be changed. This could be a tool that you can deploy whenever other tools are not available or don't fit your use case, because it's very generic, so you can deploy it easily. Other optimized solution that would address the problem that you mentioned for TLS, of course, is possible and is part of the proposal here. Let's try to work on a solution. Composite crypto could be one. Others can come out from above, for example, or for a work group or other things, but it's a problem that we need to address.
Okay, I'm going to cut it right here because we're more than close to 3 minutes over. So I think this work seems to be more appropriate to lamps. So Max, I suggest you keep this.
Lamps sends us here. And if you send us back to lamps, we'll be back to lamps. It's okay.
Yeah, I think we've gone through this with some other stuff in the past where Lamps wasn't sure if other folks, if there was broader applicability, and they bumped it up to Secdispatch. We said, nope, it seems scope to that. And I think that the conclusion we have here, based on the comments from the floor, is that this doesn't, it's not really appropriate to broader situations like TLS. So it's appropriate to consider in that narrow scope. Does that seem like generally okay to people? We'll confirm this. I'll tell you what, let's not have further discussion. We'll confirm this on the list.
So what is the solution, the resolution?
The draft resolution to be confirmed on the list is to dispatch this to Lamps.
Okay. Thank you.
Well, Max, you're the next presenter.
Okay, I'm Max, still with Cable Labs. So this is another presentation about the cost of revocation information delivery for public key infrastructures. Where do we come from? So one important step in validating certificates is to check for the availability of revocation information. So if there's compromise or something that you shouldn't trust and is in validity period. Now, the deployment of revocation infrastructure comes with some prices attached to it. Mostly because OCSP doesn't scale for very large PKIs, and costs are directly proportional to the size of the certificate population. And we work in the past with different techniques to try to optimize the deployment of OCSP responder, especially for high-frequency environments, where we pre-compute responses and we deploy and deliver the responses with through CDNs. I want to provide 3 considerations that spark this work. The first one is the larger the PKI, as I said before, the larger the PKI, the higher the cost of providing good revocation infrastructure is. In general, best practices today, we pre-sign one response for each certificate that is in the validity period. And in particular, what we notice is that what we sign over and over again is here there's no revocation information. The only difference is the serial number, but it's the same type of signature. And think about the situation for CSP, large CSPs, where they manage hundreds, if not thousands of different CAs, each of which can have millions of certificates, especially when we think about one of the last consideration. Can we do something to optimize for the most common case where the certificate is valid? So there's no additional information that we actually want to provide. The second consideration is about when you ask the status of a certificate, usually what you really want to know is this certificate, the old chain is valid to something that I trust. Can we limit the number of needed round trips? So some discussion went on the mailing list about this, and some people pointed out that the OCSP, since 2560, allows the responder to attach multiple responses, even if the client doesn't ask for multiple requests. But this is never being used to convey the full status of the chain because of, I think, some trust issues that we're going to look into a little later. But one of the points that I'm trying to make is that maybe we can do something to provide the full chain information to the client in such a way that the client can really trust that information. The third and last consideration is that in the IETF, we focus on the internet PKI, where the trust model uses mostly certificate on the server side and other techniques to authenticate the client side. But recently we've seen the born of new environments. For example, IoTs, but industrial, and the industry that I work with, cable, where we have huge PKIs, or PKIs tend to grow in size. And in these environments, client-side revocation is even more costly and can drive up the cost of certificates. Now, how do we address the distribution of revocation information today? Mostly through CRLs or OCSP. And other proprietary methods, but I'm not going through that because the list would be infinite. So, how do we do with CRLs? Well, CRLs is a list of authenticated serial numbers that's signed by the CA or delegated by the CA that says that these certificates should not be trusted anymore for different reasons, and there's extensions for that. The problem with CRLs, and this is why we actually shift mostly to OCSP, is that the size of the CRL is fairly unpredictable, tend to grow beyond acceptable sizes, and it grows with revocation event and shrinks with expiration events. So it's very unpredictable. It was noted on the mailing list that we can use the issuer distribution point to bound the worst case scenario. However, this is a static partition, as we noticed. So maybe some approach to ranges could fix this problem. Okay. So OCSP responses, we have to calculate every single OCSP response. There's a problem in conveying the full chain here, because an OCSP response today could be signed by the CA. And if you try to say that CA says, this certificate is not revoked, I'm not revoked, and my parent CA is not revoked, probably is not the great trust model. But we could potentially attach OCSP responses signed by responder up in the chain, and so limiting the round trips. Just to give you an example of the proposal here is to do range queries in a PKI. This is an extreme example, but in a PKI that you have 11.5 million certificates and only 3 revocations, with doing range queries, you have to sign the 3 different certificate revocation plus the intermediate between them. So with 2x plus 1 signatures, you can provide the same information than instead of signing 11.5 million certificates. It's an extreme example, but this is the type of optimization that we're looking for. So a discussion on the list, there's been agreement that we have these limitations today. There's no really way to go around that. We have a mixed approach to the proposed, right? Not everybody agrees on the proposals, and this is perfectly fine. We're looking to spark the discussion and maybe to see if there's some work that can be done there. Two last comments. Some requests for some figures. How can we save in costs, right? Probably the real dollar cost will be difficult to provide because this is usually secret sauce, but we can provide the ratio of revoked against population, because this solution actually changes one property. The costs are not related to the active population in this case, but are related to the revoked entries in the population. So far, we have received very strong feedback from major CSPs. DigiCert committed to say, well, we really think that we should work on this. We like the idea, but and we will deploy the idea. In our industry as well, we really need to find a practical solution.
Okay, so to kick off discussion here, and again, keep this focused on those dispatch outcomes, I think the chairs would propose that this piece of work looks about the right size for something like a small focused working group. It seems not like something that fits with an existing working group, and probably too big to be something AD sponsored. So that's our initial proposal. With that, please discuss.
Sure. It's a little hard in this discussion about doing any protocol engineering because, like, it seems like there's a relatively obvious solution to this problem that doesn't require much protocol engineering, which is do Merkle signatures, Merkle trees. And then you would have to do basically one signature and then solution, and then all you need is a way to pickle that. So I'm not sure we need a working group. So I guess I'd like to see some more evidence. This is actually a very hard problem before spin up a working group for it.
Yeah. Well, yeah. So just to queue up the rest of the folks who might comment on this, the important question here is there work to do? And if so, is it
right? Right. So I think before I would sign on for the work to do, I'd like to see some evidence that actually was a computational cost. This seems like actually a pretty low cost based on what I know how CAs operate. So I'm a little surprised that this is considered to be a big deal.
Philhan Baker. I support this work. And I actually proposed this exact solution in '98 when we had the issuing patent distribution point patent dispute issue. To respond to Eka, yes, the Micali revocation trees or Koshta revocation trees are another approach. I'm not sure. I think we'd have to consider which one. But the other thing that you might want to consider is the work that I did with Rob Stradling, which was on CRL compression. You can actually compress CRLs. And if we're going to change the format, maybe what we should do is to do one change. And so that might be worth thinking as well. If we're going to do it, I think the natural place to dispatch it to would be LAMPS.
Gary Mundium, Qualcomm. Since you're coming from Cable Labs, I'll mention what we did for ATSC, which is the over-the-air television broadcast standard that's commonly used in North America and other countries. We actually used OCSP as is, but we stapled the OCSP responses to specifically broadcast emissions. So if you're interested in, for instance, channel A, you set your tuner on channel A. The client only receives the OCSP responses that are related to the certificates associated with channel B. If you want channel B responses, you tune to channel B. We were able to use OCSP as is. Just used it in the staple in the way it was intended to be for OCSP stapling. I don't think that you necessarily have to change OCSP for that. I think it's more a question of how do you actually narrow the amount of responses that the client is actually interested in and allow the client to discover places to obtain those responses rather than coming up with new signaling.
All right. Sean Leonard, Penango Inc. So having read this, I do support this work, and I think bless your heart for trying to continue to improve OCSP multiple times, I guess, and coming back to IETF for this kind of work. What I think is different and is very valuable is for those who are skeptical of this work to be convinced otherwise, is to see the data, right, in practice, the telemetry of how much time, resources, energy, whatever round trips can be saved from the different techniques that are being proposed, especially whether it's WebPKI or other PKI deployments. That will help, I think, motivate a lot more support for different use cases and different kinds of data structures. So I'd love to see that data, from what we've seen in the field, from what practicing providers can give as part of this work.
Yeah, we have like less than 90 seconds, so be quick.
Hi, I'm Tadahiko from Secom. We work for Certificate Authority and we make some IoT system also. And we really want those kind of systems.
Can you please get closer to the mic?
We really want those kind of system because like current OCSP is not scalable at all and we're having very big problem. So I really support that one. It's like just comment. Yeah.
Nick Sullivan, Cloudflare. We cache a lot of the web's OCSP responses. I don't see a need for this work. I'd like to see more data to justify doing work like this. OCSP seems to be working fine.
Daniel Kahn Gilmore. I'm curious to know whether you've thought about how this interacts with OCSP stapling. Are you expecting to ship the range in the stapled region during the TLS handshake? And if so, what is the client going to do who doesn't understand this when they see a range? Is it going to break the stapling? I'm not sure you need to answer that question right now since you have negative 60 seconds, but it seems like a potentially problematic situation.
This is potential work for a work group or, collaborating on finding a solution.
So yeah, I think so it sounds like nobody objected at least to this idea that if we're going to do any work here, then it should be in a new small working group. I think we can have some discussion on this to confirm that there's energy to do work here at all. So thanks, Max. I'm going to call up Nick Sullivan next, if that's all right. We've had a last minute agenda batch proposed to the chairs directly. We're just going to swap the next two proposals. So we're going to do Nick and then Justin, if that's all right. Okay. Yeah, the conclusion on that last one is that if we're going to do anything, it's going to be new working group material, and we're going to confirm whether there's to be a new working group on the mailing list. Please, Roman.
And I would add there was interest in kind of additional evidence if it can be provided to help with the discussion.
Yeah, thank you. All right, Nick, please.
Okay, so Privacy Pass. This is a technology that was presented previously at Perigee, and I'm going to go into what it is and what the interest is in it. So Privacy Pass is a lightweight zero-knowledge protocol for the web. The motivation here is, wouldn't it be nice to have some online equivalent to cache, something like talking to one service and being issued some sort of credit that you could spend at another service, or such that it's unlinkable. The person who issued the credit to you is unable to know where you spent it. And this would be something that'd be nice to have and to work at internet scale. There's a specific problem that this solved for us, and I'm going to go into this. So just some sort of physical motivation here to how this could potentially work. Imagine having an envelope, writing a serial number on it, adding a piece of carbon paper in there, sealing it up, and sending it to an issuer that would sign the envelope with saying this is legal tender without knowing what the serial number is. You'd open it up, and then you have legal tender that you could spend somewhere else. So the issuer does not know the serial number, and it's something that you could use somewhere else. So Privacy Pass is essentially the digital version of this. This idea has been around since the 80s, but this is something that we found more recently have updated to use, I guess, more efficient cryptography. This is a paper from PETS that was published by myself and a couple co-authors. The solution here, or the problem space here, was for solving CAPTCHAs, specifically solving CAPTCHAs on multiple different websites, so that your experience of solving CAPTCHAs is that you see fewer CAPTCHAs. So you can imagine if there's 100 different websites, they all have the same CAPTCHA provider, and if you solve a CAPTCHA on one website, you get a cookie that proves that you solved that CAPTCHA. This cookie is not transferable from one website to the other without leaking your identity. So what would be nice is to be able to get some anonymous proof that you solved this CAPTCHA and be able to redeem it to bypass another CAPTCHA. So this is the flow this is how Privacy Pass works. So you take a token, you blind it up, you send it to the CAPTCHA provider, they sign the blinded token, send it back to you, and then the next time that you encounter a CAPTCHA, you unblind the token and you send it to the CAPTCHA provider, and it's able to verify that this was a valid token, but not know which site it was that issued it or who the issuer was. And so there's two constructions underneath that make this possible. Blinded RSA, this is the original eCash scheme. This has the feature that these tokens are publicly verifiable, so one party can issue and any party can verify. The version that we came up with for Privacy Pass is called VOPRF. This is this is actually currently being looked at the CFRG. That's been adopted as a working group item to define how this works. It's a oblivious pseudo-random function with verifiability. Essentially, the only difference with blinded RSA is that it uses elliptic curves. It's more efficient, and it's verifiable by only the issuer, which is a slight constraint that gets you the performance. Now, Privacy Pass itself has running code. We have the code is open source. I have 1 minute. Okay, great. So there's a Firefox and Chrome extension. This is actively used by over 130,000 people per day, per week, 500,000 redemptions or so. This number's probably gone up quite a bit, and we recently released a new version. And so the reason I'm coming here is this technology seems to be useful more generally, and there's been a number of different applications to this that have popped up. Specifically within the Brave browser doing ad confirmations. The Privacy Sandbox proposal from Chromium is interested in using this specific technology. Facebook has also proposed something similar, and the Tahoe LAFS project has committed to using basically the exact same construction. So the idea here is that we would standardize this and go forward, and it would be useful in multiple of these applications. Okay, so I know I'm sort of a little bit over or not.
No, you're fine.
Okay.
Assessment, you have like 2 minutes.
Okay, great. So I'm almost done here. So what is the scope of work to be done? What am I asking? Well, defining the basic privacy protocol in terms of HTTP headers. How do you integrate the crypto? And if there's specific features to the use cases listed, can we support those? And so perhaps this is a mini working group sized amount of work, maybe a full working group sized amount of work. It's not clear. This is why we're here at Dispatch. If we were to do a working group, this is sort of the proposed charter. Essentially, tokens are issued in groups. These groups form an anonymity set. Any issued token can be confirmed to be part of a group and can be submitted to be verified. And the verifier can only prove that this was one of the tokens of the group, not link it to the specific issuance. And so what we'd like to do and what is defined in this draft, which is posted on the list, is to specify a protocol that provides this mechanism with the security properties and how to use this in an HTTPS client server setting. It's not a goal to build an interoperable federated system with multiple token issuers. This is a basic protocol. And there is one additional request to define a way to embed a small amount of metadata, say 1 bit, into the token. So with that,
yeah,
questions?
So I remember talking to you about this, and one of the differences is the fact that the original proposal could be verified offline and this can't, right?
That's correct.
So I was wondering whether that could be brought, or is there a way to bring that back? I've got use cases which this would be perfect for, but offline verification would be really, really useful.
Yeah, I believe that should be in scope, having a publicly verifiable and a online issuer verifiable version. I think those are two very solid use cases, and we've had requests for both.
Perfect, thank you.
Could you state your name for the minutes, please?
Oh, sorry, Leif Johansson.
Eric Scrolla, thanks for bringing this. This is cool stuff. I think I think you're right to think of me working for the right thing. There's enough stuff here that probably it can't just be like an HTTP extension. I agree with Leif. It would be good to have offline use case as part of the as part of the charter, which I think actually brings us to the point of algorithm majority. In the sense that certainly I assume you're not using RSA as performance
and token size?
Yeah, RSA, the reason we switched from RSA to VOPRFs was performance and the fact that we didn't need offline, but I don't see why you wouldn't be able to support both.
Right. Well, so you could also do BLS, which is blending. I think
I would caution against BLS until getting from the CFRG, but again, that's happening.
So I guess the question I do have is there any new crypto engineering here that we're going to need to round trip through CFRG? My understanding is VOPRFs are already being done, and that we understand how to do the one or two bits of metadata with Stephen's scheme without having to like invent a bunch of like zero knowledge proofs and stuff like that, right?
Yeah, so the hope is that this would run in parallel with the CFRG process for VOPRFs. And if there was a requirement for public verifiability, then maybe a new work item to bring Chalmian blinded RSA into CFRG could be useful.
Right. So this seems like quite appropriate.
Stephen Valdez, Google. I think this work is interesting. I think including in the charter the ability to have further extensions like that, private metadata, additional bits of data would be useful. I think there is still crypto work to be done. We had a scheme for the private metadata, but there was an issue with that you were able to discover whether or not two users had the same bit there. And I think we probably want to get more eyes both from CFRG and people looking at these protocols specifically before we call anything working and not needing further work.
I think let's make Matt Miller the last comment here, please. Sorry, Mark.
Right. I'll go quickly. I just want to express that I think there's a bunch of use cases for this work, as you showed a couple slides ago. So I'm interested in work. I'd like to see it move forward and help out with that.
Yaron Sheffer, I support this group. I think it's well worth a working group in and of itself. I am worried about a working group where a core tenet is that interoperability is out of scope. So I urge you to find the areas where you do require interoperability.
Yeah, that's a good point. Maybe it's just federation that's out of scope, but interoperability is in scope. That's a very good comment.
Echoing for Kobe Gherkin, I support this work. I'd like to see this blind signature-based protocol moving forward. Would be willing to participate in a working group.
Just from an HTTP perspective, I think a separate group is probably the right answer here. There's enough meaty stuff to do, but please coordinate, because I think there's things like cache interactions and intermediary interactions you want to take care of.
Thanks.
Mark Nottingham, could you please state your name for the record?
My name is Richard Barnes, or Mark Nottingham, I'm not sure.
All right, and because we're bad at estimating time up here, I'm going to go ahead and let our remote speaker go.
Hi, this is Rajanur from Intuition Machine. I'd just like to say we support this work. We already have an interop with the existing implementation from Cloudflare, and we'd like to see it go forward. Happy to participate in the working group. Thank you.
Thank you.
Yeah, so that's a clarifying point on the interop point of view. The recent release that we did is interoperable with multiple CAPTCHA providers rather than just Cloudflare and the Cloudflare extension. So it's one extension, multiple providers, but the mechanism for federation is not in scope.
Cool. All right, so it sounds like there's, I think you're probably about right that this is about micro working group sized, and it sounds like there's several expressions of interest from the floor. So I think let's workshop the charter on the list, and AD is willing, we can probably just charter this directly without further buffitude. Chairs to the mic, please, or ADs to the mic, please.
Roman Danelli. So continue to talk on the list for charter text is great. I think we want to buff it, but let's put the text on the list. Let's chat kind of a little more, and we'll make some plans, since that what we're talking about is 3-4 months from now.
Okay. Thank you.
Thanks, Nick. All right, Justin, you're up. Wake up. There are stairs over there.
All right, so for any of you who were at Dispatch yesterday and saw the same presentation, this is the slightly slower version of it. Slightly, yes. I'm running it at probably about 2/3 Eckerd's right now. So anyway, I wanted to talk about HTTP signing. Specifically, what I'm talking about is a message level signature over an HTTP request. And that's a signature that would cover some subset of the headers, the body, other request elements like the URL and verb and all of that other stuff. And in particular, we're interested in talking about detached signatures and not encapsulated signatures. More on that in just a bit. The reason that there's a lot of people out there interested in solving this is pretty varied. As it turns out, people have been approaching this in order to prove possession of a specific key. There are security protocols, extensions to OAuth, and the like that are, you want to have some way to say that I have a particular application level key. You want to be able to authenticate a piece of software, which is a slightly different but related problem to key proof of possession. You want to have sometimes message level integrity. This goes beyond the TLS transport layer integrity, and also non-repudiation and audit kind of, I've got a signature over the request itself that might last in logs and things, going forward. So the reason that this is a hard problem and we don't already have something built in is actually not the signature part. The reason that this is hard is because of HTTP. HTTP gets transformed and terminated and parsed and reconstituted and replayed all over the place. It's designed to be able to do that, and we kind of expect it to be able to do that in our systems today. However, we don't want to just encapsulate the entire HTTP message to prevent it from being modified, because we want our terminating proxies to be able to look at something and parse it and figure out and then hand that back to our backend systems and add in their own headers and all sorts of stuff like that. We need to have those kinds of capabilities in our apps today. And it's really, really common, especially with things at the application level, to parse and reserialize stuff. So things like query parameters tend to get handed down at the application layer as a map of some type and not as the query string. Things like a JSON body is going to be handed to you as an object and not as the series of bits of the JSON, the HTTP message entity payload itself, right? Parsing and reserialization is really, really super common. All of this makes signing any of that really, really, really difficult. You inevitably need to have some type of canonicalization and normalization process in order to make this thing work. So, first question, why aren't we solving this using other existing technologies? So, why can't we just use TLS for everything? Well, TLS stops at the TLS terminator, thus the name. And in a lot of cases, in a lot of applications, you need both the integrity protection and the key proofing to go beyond the TLS terminator. Additionally, there are a lot of applications where mutual TLS doesn't really fly. Anything that's being generated inside of a web browser, so in an SPA or something like that, doing MTLS from inside there really doesn't work. It is a horrible user experience. People get prompted for personal certificates because of assumptions that we have made on the internet about what a certificate in a browser means and stands for that don't really map to the way that we'd like to potentially use the technology. All right. What about SHTTP? This got brought up, I believe, is on dispatch list, not on Secdispatch, I forget. But there's, and no, I don't mean HTTPS, I mean SHTTP. This is an old RFC that wraps up HTTP in an encapsulated message, and it duplicates and hides a bunch of HTTP functionality in order to do the encapsulation. But the biggest problem is that it exists, but nobody's ever heard of it, right? Yes.
So,
question.
Martin Thompson, a correction here. I think that HTTP was raised as an example of how this has been done in the past, and perhaps there were some lessons to be learned from it. Not to say just use SHTTP because there's an RFC.
Right, and I did not intend to imply that that was what was claimed, and which is a good thing because we shouldn't just use SHTTP for lots of reasons, not the least of which is that it's an encapsulation protocol. Are we taking questions in the middle here, or should we tell Phil to sit down? Okay. Awesome. Thank you. All right. So what about using Jose? A lot of people love this for lots of things. The thing about Jose is that it's really, really good at signing its payload that it carries along with it. And again, if you're doing some type of detached signature, you need a way to get that payload into the Jose world and then get it back out so that you can carry the signature along. It's not really set up to do this kind of thing. And if we were to encapsulate all of the HTTP stuff, so put the verbs and the actions and the URLs and queries and everything inside a Jose object and just stuff that inside of an HTTP request, you end up with SOAP with curly braces. And let's really not go there, all right? So looking around there, and the reason I wanted to bring this into Secdispatch is that there are at least 5 options out there. There are actually now 7, thanks to Annabelle publishing 2 more this week. But to be fair, those are a remix of one of the ones up here, so I didn't update the slides. And I am personally responsible for 2 of these, which are different from each other because reasons. And all of these exist today and are incompatible with each other and solve slightly different slices of the overall problem. So cabbage signatures, which is probably one of the, yes?
So, Martin Thompson, I can add at least 2 more to that list.
Oh, yeah, I'm sure. I said at least. There's people have been hashing this in different ways. So, and I should add, these are specifically the detached, non-encapsulated versions. If you want to go encapsulated signed HTTP requests, there's like, you can't throw a dead rat around here without running into one. There's a lot. So I'm talking about specifically detached stuff here. Cabbage signatures are probably one of the most widely used ones out there. They're a little bit limited about what they can canonicalize and sign, but kind of works. One of the worst things about this particular draft, though, is that it is entirely detached from the IETF process. It is an ID that people outside the IETF have been working on and updating and changing. More on that in a moment. And it's just kind of there, but people are using it. OAuth depop and OAuth pop, which, yes, those are 2 completely different things. And as you can see, they attack different parts of the problem. Depop is all about key proof of possession, whereas OAuth pop is about token presentation and a message integrity component with a key proof of presentation that kind of comes along for the ride. And that latter one is also an expired working group draft because, it never really kind of caught on. The new XYZ project that I've been working on, which we talked about the TX BOF the other day, all that does is it signs the body. It doesn't touch anything else. So that is extremely limited, but it has its uses as well. And then there's the proprietary AWS v4, which predates pretty much all of these, which has its own really, really major limitations. Even though it manages to cover a lot of the columns here, its major limitations is that it's very tightly fit to AWS's keying infrastructure with its key derivation functions and stuff like that you have to do in order to make this work. Right? Yes. Less than a minute. Okay. Well, So the Cabbage signature draft that I mentioned before started way back in 2013 as an individual draft. It got picked up by a bunch of people. And then earlier this year, including a couple of financial groups, and earlier this year, the editors of that draft made a bunch of edits, which included the text, "Do not use this draft." And that freaked everybody out that was depending on this. And there was a scramble to peg against a particular version, and then there's been more updates and stuff like that. And all of this kind of led me to realize that, you know, enough people are using this stuff, enough people are trying to reinvent this stuff. I think it's time that we brought this into the fold and make this a real thing that people can depend on for, you know, stability and all of the IETF process and whatnot. So where do we go from here? I don't actually know. Should we combine all of these drafts and all of these different use cases? Should we find a working group where this makes sense? We talked about potentially targeting this at the HTTP working group, at the dispatch thing. Should we start a new working group to do just this one thing? I don't actually know. So with that, we'll do comments and questions.
So what about bringing this to HTTP working group? Mark, maybe you want to say something about that?
Does Mark want to jump the queue for that, maybe?
and also keep these short. Again, we have 5 minutes.
Mark Nottingham. So this has been, I think, as I mentioned before, this has been an item that the working group HTTP working group has had its eyes on for a while, especially Cabbage, but other things. And the confusion in this space is one reason we've been a little bit reticent to start work. From what you're saying, and obviously you're more engaged in those communities than we've been, it sounds like it might be time to start some work. So I would support some work in this area. As you kind of alluded to, I think the three different groups of folks who need to be involved here. One is the users of the potential users of this technology.
Right.
Another is the security folks, of course. And another is the HTTP community to make sure that it's integrated into the protocol well. And as you mentioned, that's kind of the tricky part of all of this.
Right.
So I had a quick chat with my co-chair just now, and I think we'd be happy to consider a call for adoption if you're interested. If you want to dispatch this elsewhere, that's fine too, but I'd request that UADs talk to RIDs so we can do some coordination and figure out the best place for it to land if that's going to happen.
Yeah,
I would consider this in the scope of our charter.
That honestly would be fantastic. We'll figure it out with the ADs. When I initially brought this up with the SEC ADs, the thought was that this really is on the line between the two areas, and we do need people from both sides.
Of course.
So, but yes, thank you.
Hi, Phil. I'm Baker. Actually, I was going to say that I don't see it being online. I think it's your work is going to be entirely HTTP.
Okay.
It wasn't just Eric who tried to do this stuff back in the day. I did it as well. But encapsulation is actually the way to go. You're onto a lose here. Canonicalization always loses.
Out of scope. Thank you.
So
maybe a silly question, Aaron Scheffer. Have you actually talked to the Cabbage authors?
Yes, and they asked me to present this. Yeah, so I talked to Manu Sporny specifically about this, and he is keen on getting this targeted to an actual place now. So here we are.
So we're cutting the line here.
Okay. Martin Thompson, I spoke to Cabbage about this one probably 5 years ago now, and he was quite keen to have it go here, but wasn't really able to invest the effort required to get it over the line. I'm glad that someone's willing to do that. This is really tricky from an integration perspective, though, and I caution that comments like PHB's just now are quite valid, and I think that we have to think about that in this context very carefully. I realize that people are using this. But there's a tension that this creates between endpoints and intermediaries and protocol actors within HTTP that make it very tricky.
Oh, yeah.
So my suggestion would be that the primary venue for this one would be the HTTP side of things, and we would bring in expertise. The crypto expertise that you need in order to do something like this is a little sophisticated, so we will definitely need some help there, but it's still fairly basic stuff. But the tricky part is getting it in the protocol. So I would encourage people to go there.
Yeah, I'm absolutely with you.
Annabelle Backman, Amazon. A couple of quick points. First of all, since we've been operating Signature version 4 as our main request authentication mechanism for years now. We can attest to the viability of a detached signature protocol at scale across a wide variety of services with a wide variety of API formats. Encapsulation is not the only way that this can be done. In addition to that, Justin mentioned me putting forward 2 other drafts. What I've done is taken the expired draft that Justin wrote, the OAuth POP spec, and split it out into 2 different layers, pulling the HTTP message signing pieces out into its own piece, independent from all of the OAuth specific details of how you attach that, how you put that message into the request, what do you need to sign, whatnot. I really think that kind of layered approach is the right strategy here. All of the work related specifically to signing elements of an HTTP message, that belongs in HTTP. How you apply that in specific context, for example, to do proof of possession for OAuth, is something that the OAuth working group can handle, and other working groups can leverage that signing work as well as appropriate to their use case.
Yeah, I agree. Everything that we've had so far has been very packed together. I think we might see multiple drafts out of this.
And I'd be happy to put forward the message signing draft in the HTTP working group, submit it there and hold the pen on that if we need people to pick that work up.
Okay, so it seems pretty clear that this is going to HTTP, so we can move on.
Yeah, pending coordination with chairs, it seems like this is probably going to be an HTTP work item. Does that sound fair? Okay. Cool. Thank you.
Joachim?
Hello, my name is Joachim Fabini. This work that I will present has been planned for a researching group, IETF research group that unfortunately has not been chartered. So I'm here to ask for feedback, whether this is research or engineering, or if you have suggestions where to go with. So the background of this work is the concept of systems as has been defined by the IETF. So the past incidents have proven that systems can no longer be considered secure. We have vulnerabilities at all layers, starting with Spectre, meltdown from hardware, and then going up to upper layers. So vulnerabilities do exist in these systems, and it is a question of matter and time and resources to exploit these vulnerabilities. System complexity is no longer manageable. All of these vulnerabilities, they are packed in one module that is reused by someone else. You purchase hardware designs, integrate it into your design. So it is this concept of having or improving the security of a system is somehow outdated. Moreover, we are focusing on the area of critical infrastructures where monocultures are developing. So operators have incentives to have just one single hardware design, to operate one single firmware and have one single software on hundreds of thousands or tens of thousands of devices. Think about smart meters and so on. In RFC 3552, it is stated that protecting against an attack when one of the end systems has been compromised is extraordinarily difficult. And we have asked ourselves, what does compromised mean in this context? So it is obvious this is a required statement. It is very important to have this chain of trust between systems, because otherwise we can't do anything. But the systems are vulnerable, that's a fact. So, and malware intends to exploit these vulnerabilities. We need some solutions. We need to better than saying we give up whenever one system in a chain of 1,000 systems is infected. So we need to isolate, we need to contain all of these devices. As an example, and the challenge here is that these devices are low cost that we're talking about, and they have adversaries have physical access to these devices. Electrical vehicle charging stations now are updated to 350 kilowatts, which corresponds to more than 500 households of energy consumption. And it's a matter of loosening some screws and accessing the device to compromise it. Good. In parallel, security protocols are deployed at large scale now. And in the lowest line, you have a reference that points out that this security might also create a platform for malware to propagate and do subliminal channels and secret communications or hidden communications, which might be very difficult to detect. So what we've done here is just to implement a command and control structure for botnets using Bitcoin in the blockchain. So in the signature, we embedded some commands that were then taken and adopted by clients. Good. The motivation of this work is that malware has incentives to communicate. We want to discover this communication between malware instances. The more communication, we argue, the more important it is, and the higher the threat that this malware can cause overall in a large system. The challenges are high because malware has started recently, so current malware variants already monitor the traffic, the benign traffic on the network, and try to obfuscate within this traffic, to use the same protocols to encrypt data, and so on and so on. What we propose is to complement existing security measures. That is, we do not want to say we replace them, but we want to provide additional means of security. As a proactive measures, we want to inhibit malware communication by design, meaning we have shown in signatures of the bot chain it is possible to include command and control structures. How is it with other protocols? That is, to evaluate the potential of hidden communication in these protocols that are used in critical infrastructures. And but my talk now is about reactive measures, and that's a draft also about we want to detect this hidden communication. And what we did is, and the research question is here, can we detect and capture malware behavior in these networks? What we did was to design a generic malware lifecycle model, which basically captures the behavior of known malware variants in the wild. And if you look carefully, this diagram here equals the concept of compromise in the current IETF security concept. So what does compromise really mean? Does it mean we have infection? Does it mean we have gained access to a system? Does it mean we have control over the system? So it is a much finer granularity, and we believe that, and the essence is that we have various states, and these states are subject to communication to change. So we have transitions between the states that you see, cyclic ones and so on. We have scans that also originate traffic. We want to capture this traffic as a monitoring part and to infer on the existence of malware to detect anomalies in the network. 2 minutes. Thank you. Oh, I'll do fine. Good. So, and now the question is, how can we use this life cycle model to improve the security of systems? As a future research question, we discussed it before in a site meeting, and the conclusion was it's challenging. It's very challenging. So can we quantify, can we define metrics to quantify the behavior and the support for subliminal channels within existing security protocols? Good. As an outlook, so this generic malware lifecycle is something that we perceive could help to improve future evolution of security, to give an additional potential and additional security for, in particular, for critical infrastructures. Now, the question is, is this the home for this work? Is it IETF? Is it IETF? Are there specific groups where this fits in? We have a funded research project now that combines various stakeholders. So we have a ministry, we have 2 utilities, we have 3 research institutions, an antivirus company that all team up together to research on the challenges in the current e-vehicle infrastructure. We start at a very low level if you know how the current state of electrical vehicle charging is with respect to security, but we hope to get some good results. And yes, we believe that the results are of relevance. And if there is any feedback and any opinion where this should go to, I'll be happy to get feedback. Thank you.
Hello? Okay. So it's not clear to me exactly what you're trying to propose. I'm not sure that the generic working on malware is appropriate for the IETF. There are nuggets in here that talk about proactive measurements, rates, and protocols. Perhaps that could go into like the MapRG, as they've done. So in this session, for example, there was presentations on different measurements for detection of anomalies, if you will. But as a whole, I guess I'm kind of struggling to figure out how to dispatch because it's somewhat broad. So with that, I'm going to do the quick discussion before we figure out how to help provide guidance.
Good. So, right, it is also about measurements. It is about anomaly detection mainly, because the challenge will not be the measurement itself, but the focus will be the anomaly detection of these anomalies in encrypted traffic. Finally, so it spans several areas that are, yeah.
So let's have our RAD comment.
Hi, Roman Danilio. I was just hoping, can you talk a little bit more about that first bullet? No, on that slide. It was, so can you talk a little bit more about the specifics of that lifecycle model there and how you see that manifesting in IETF work?
This lifecycle model is supposed to be mapped to the security model that we have in RFC 3552. So about the compromised point here. Right now, when do we consider a system being compromised? So when do we stop current IETF activities, basically, if we take it this way, saying that the system has been compromised, so it is extraordinarily difficult to defend against. We believe that we can do better by adding additional functionality to all of these mechanisms.
So it's a resilience thing we're talking about?
It is a resilience, yeah. Resilience, it is an additional feature. It is supposed to be a monitoring device that monitors a critical infrastructure at packet level, traces. So this is related to measurements then. But it is related also, how can we process all of this data? It will be an enormous amount of data, all of this data. And it is finally about malware behavior. How does malware behave? How can I, if I have the life cycle diagram, all of these transitions are characterized by specific features. So, for instance, triggering a scan or a discovery might cause a lot of traffic, might cause less traffic, depending on the on the kind of activity. Whether I trigger a blind scan, a topological scan, or a passive scan, or a control message will be small, and I have no causal. I have a causal dependence between a message arriving at the malware at an infected instance and causing an attack, but I have no temporal, no chronological dependence. So I do not know. I have received a message in the past, and in the future it will trigger an action.
Okay, I'm going to cut the line at Gary.
Eric Scorla. So, and there's some interesting stuff in here. As we discussed previously, I think that the focus of subliminal channels is kind of a distraction. We at IETF kind of collectively decided not to like really make an effort to reduce subliminal channels in cryptographic protocols, and there's like an enormous amount of like literature on that like probably is not worth recapitulating. But I think certainly, like, malware is a real thing. But I do have a suggestion for you, which is there's currently a IAB program. I think it's called Model T, is what they're calling it, about looking at the threat model for the IETF and discussing potentially revisiting 3552. Since this isn't really a protocol specification, but it is working at the threat model and about malware, I would suggest that you take it there. I don't know if Stephen Farrell's in the room. He's leading that program. But in any case, it's not hard to find.
Okay, thank you.
Yeah, so I just wonder about why you think there's value in forming a malware lifecycle model when a lot of network equipment today already come equipped with intrusion detection systems based on adaptive technologies such as onboard machine learning engines. By the way, Gary Mundy from Qualcomm. I know my company makes access point processors with onboard machine learning engines. I wouldn't really try to solve this problem, forming a life cycle model more than I would actually try to train an engine based on traffic characteristics that I expect to be normal within the private network. So why do you think this is a better approach versus something more adaptive?
This is a better approach because we have a finer granularity on these attacks. We can detect when we want to detect when a specific malware is in a specific stage of its evolution. So we want it's what IDS are doing. However, most IDSs are still pattern based. They're trying now to do machine learning based. That's what we do too. But however, this granularity, having intelligence that adds on specific tasks and activities of a malware in critical infrastructures, and we have also architectural. I didn't mention this, but we have architectural topics there to isolate and part of this architecture, part of the subsystems from the rest of the systems, trying to maintain the functionality of the rest of the system. So it is a kind of resilience, yeah.
Yeah, I mean, I would say that it's hard to measure success of an approach like this if you cannot say, well, I can easily deploy this model and keep the false alarm
So
rate
Gary,
down to
I'm sorry,
acceptable
we
level.
gotta wrap this up. And Ted, one quick last comment.
Ted Hardy, just a clarification to a point that Ecker was making. Model T is not yet a program. There's a mailing list and some active discussion. And certainly if you talk to Stephen, he'd be happy to add you to the mailing list and you can join that discussion. But if you're scrambling to go to the IBA website and go, where is this program? Oh, wait, there's nothing here. That's why.
So
okay, thank you.
Yeah, I think the chair has been talking ADs, back channeling with the ADs. I think that's probably the best next step for you to talk with those Model T folks. All right, thanks. And finally, Brian Campbell. We got 5 minutes left for you. To talk to the IAB Model T proposed program. It's the threat model evolution.
All right, try to do this in a few minutes. I want to talk about conveying client certificate information. A lot of words here. From TLS terminating reverse proxies to backend HTTP applications. Quick kind of overview of the problem statement is that in a lot of HTTPS application deployments, oftentimes TLS is terminated by some reverse proxy that sits in front of the actual application somewhere. This is true in a lot of different architectures. In the kind of old-fashioned sort of in-tier reverse proxy and back-end origin server architecture. It's true now with things like you see with CDN as a service type offerings or application load balancing type offering services. And you're also seeing it even in microservice type deployments where you have this sidecar proxy pattern. So even though things are changing, it's a recurring pattern of TLS is terminated somewhere up front, and the backend application isn't talking TLS with the clients, but terminated by this other component. And TLS client certificate authentication is in fact sometimes used, and a lot of times when it's used, the actual application in the backend needs to know something about the certificate, make authorization decisions, to bind tokens to, or whatever. It needs to know more than just was the connection successfully established or not. It needs access to the actual content of the certificate. And in the absence of some standardized method of conveying the client certificate information from the proxy to the backend, different implementations have done this differently, or in some cases haven't done it at all. I want to give a quick idea, I know there's a lot of words here, of how I got here in front of Dispatch. In the OAuth working group where I spent a lot of time, there's a draft about doing mutual TLS for client authentication and binding access tokens. And in an unrelated discussion, the draft came up as we were talking about some other things, and one working list group participant basically said that some sort of protocol for conveying this information should have been defined by the MTLS OAuth document. I took that kind of hard, but luckily Ben stepped in and said that it seemed like it was something that was a little more general and probably would have been defined in a more general fashion and not specific to here. Feeling a little bit better about, less insulted by that, I agreed with him and said it would be nice if such a thing existed. But it definitely, has a wider applicability than just some narrow OAuth profile of this stuff. A couple other people piled on, saying they also agree, and specifically said, would it be possible to get this pushed off to HTTP or the TLS working group? It'd be more appropriate there, but it would be helpful to have something like that. I think you said that. Ben then said, somebody has to write a draft. This was right before the draft deadline, and said barring that, hot RFC or Secdispatch might be a way to take this. I wouldn't be here in time for hot RFC, so I landed here in front of you all. And I did do some conceptually similar work a while back around token binding, which is kind of died out for different reasons, but did some things really similarly and thought that maybe some of the concepts that were applied in that draft could be applied here. And basically, there's a sort of a simple proposal for how to do this, which would be, and which could potentially enable sort of turnkey, simple, interoperable integration for conveying this information between independently developed components or services, which would largely just be the normal HTTPS connection between a client and a server. That's the reverse proxy terminating TLS. That proxy sanitizes relative headers and passes the client certificate information back to the backend application as a new header with a defined name and encoding. This is sort of all that's needed to solve this problem for different components to speak to each other in different ways. And that would be sort of the proposed solution to this is to develop some kind of draft that just defines that header name, as well as the encoding certificates and the rules around header sanitization to keep things secure and not injectable from the front-end clients. Having said that, I wonder if maybe the ship has already sailed. There's lots of disparate solutions out there already, and they're all doing it in slightly different ways, exposing or as configuration options, different ways to pass different parts of the certificate. And it's not clear that retroactive adoption of a late standard like this would actually happen. And while I stumbled over the words and said it quickly, I tried to present one simple prospective solution to this. I actually think the consensus here might prove really difficult to achieve. The thread that started this discussion on the OAuth thread, even after the mention that I might come here and talk about it, degenerated into a lot of really strong opinions and even some borderline personal attacks and questions of people's motives, which was fun. When discussing at IETF 99, that particular draft around token binding, I'm out. So it's hard. There's other ways to do it. There's the forwarded extension, I don't know. Thanks for your time. I don't know if this is something we want to dispatch or not, or whether relevant work would be done, but that's kind of the overview.
Sorry, we don't have time for discussion here. To answer your question, we are not going to dispatch this because we don't have a draft. Look forward to getting some discussion on the list, and we can hopefully get this discussion.
Thank you. I know it was a time constraint thing. Would it make sense then at this point to write something up and work it through dispatch for discussion?
Yeah, I think if you get a draft going, you can post it on the Secdispatch list, and we can have some discussion there as to what might make sense. All right. Oh, so Roman?
Yeah, I just wanted to kind of remind Meta, we can use the Secdispatch mailing list all the time to talk and have proposals, and we can help with dispatching there all year round.
By all means, we don't need to isolate our activity to these meetings. We can even have virtual meetings to dispatch things in between physical meetings. So let's get that energy going. If you are interested in this topic, please chat with Brian. So just to quickly recap our outcomes today. Max's first proposal on post-quantum combination signatures. I think the feeling here was that if this work is going to get done, we're going to dispatch it to LAMPS. That's to be discussed and confirmed on the list. The chairs will start a thread on that. For Max's second one about OCSP revisions, again, I think the feeling was if there's going to be work, this should be in a new working group. There's enough work there to merit that if there's energy to do that work. So we're going to confirm that and see if there's data to support the need for this back on the mailing list. And again, chairs will start. Yeah. For Privacy Pass, there was pretty good energy in the room. Seems like there's probably energy for a working group. We'll see. We'll see. So we're going to hash out charter text in the list, and the ADs are going to advise on what process we will follow to decide whether to form a working group or not.
And if Privacy Pass wants a mailing list, we can also make a mailing list.
Fair enough. All right. The HTTP signing stuff has been dispatched to the HTTP working group, and the malware lifecycle work to Model T over at the IAB. So we have successfully spread our influence over multiple areas and the IAB. Good job, Secdispatch. And finally, if you're interested in the work that was presented last by Brian, please talk to Brian. So that is Secdispatch. Thank you for your time today. You like my auctioneer voice?
Blue sheets. Was that clear enough? Where is the second blue sheet?